Oil refining is one of the largest and most complicated businesses in the entire world. Oil refineries process and transform crude oil into a series of products for consumption as fuels: gasoline, kerosene, often used for jet fuel, diesel for cars, trucks, and heavy equipment, fuel oils used as heating oils, liquefied propane and butane, and methane, most commonly known as natural gas. Many will be surprised that not all crude oil is created equal. In fact, its properties can vary wildly due to where it was found in the world and its original plant or animal source. Crude oil was initially formed many thousands of years ago due to pressure imposed on decaying animal and plant matter. When somebody mentions crude oil, one usually thinks of a black oil, but you might be surprised that not only can crude oil be brown, it can also be green. Crude oil consists of literally thousands of different chemical compounds, principally of carbon and hydrogen atoms, hence the term hydrocarbons. The simplest hydrocarbon is methane and consists of just one carbon atom. Propane and butane are 3 and 4 carbon numbers respectively. Gasoline is typically in the range of 4 to 12 carbon atoms. On the other hand, the heaviest hydrocarbons can be as long as 40 carbon numbers long. As the carbon number increases, the compounds change from a gas at room temperature to eventually a liquid and finally to a solid. Boiling point goes up as carbon number increases. Crude oils are traded on the market based on a crude assay. It is a recognized worldwide standard that measures the percent of the crude oil that boils in 15 different predefined temperature ranges. This allows a buyer of crude to understand the relative quantity of gasoline, kerosene, diesel, and very heavy fractions. One of the major determinants in crude oil sales price is the heaviness of the crude as measured by API gravity. As the gravity decreases, the amount of heavy material in crude increases. In the diagram, you can see that the lighter crude, the 38 API crude, has more gasoline and less resid, which is the bottom material, than the 23 API crude. Lower API numbers indicate heavier crudes, less of the more valuable products, and hence a lower sales price. You often hear the term sweet or sour crudes. That refers to the amount of sulfur in crude oil. If a crude has more than 1% sulfur, it is considered to be a sour crude. The more sulfur in the crude, the lower its sales price. Crude oil is processed in many different unit operations, such as reforming, FCC, hydrotreating, alkylation, etc. The chosen unit operations depend upon the crude that the refinery was designed for and the local economics. While many unit operations are relatively standard, for example, reforming and FCC, refiners have flexibility as to how they want to process the crude. Even though a refinery is designed for a given crude, they often process more than one crude type. Usually this occurs because a crude suddenly becomes available at a discounted price in the marketplace, so-called opportunity or distress crudes. If the refinery often buys crudes on the spot market, the plant will often start bumping up against unique constraints, which can include cooling constraints, and become an aggregate sales opportunity. Products produced in a refinery must meet certain criteria, some of which depend on where the product will be used. For example, gasoline typically must not exceed a certain boiling temperature, usually around 400 degrees Fahrenheit, and must meet octane and vapor pressure specifications. Octane is the number, for example 85, 87, or 91, that you see on the pump when you're filling up your car. Higher octane numbers decrease the tendency of an engine to knock. Octane increases with increasing quantities of aromatic compounds, such as benzene. There must be enough light material in gasoline so a car can start when it's cold outside, but not so much that it causes vapor lock. That's when gasoline vaporizes in fuel lines before it gets to the fuel injectors as it becomes hotter outside. For that reason, there are 6 different vapor pressure specification zones in the U.S. for gasoline products that are ranked A through F, which vary by geographical area and season. In addition, gasoline produced for the more populated areas in the country may need to meet more stringent benzene and other specifications in order to maintain regional air quality. Kerosene must generally meet flash point and smoke point specifications. Flash point is the temperature at which the lightest components in kerosene ignite when there is a spark present. On the other hand, kerosene burns poorly when the percentage of aromatic compounds in kerosene increases. That's the reason for a smoke point limit. A large percentage of kerosene is used as jet fuel. Jet fuel has additional specifications for cloud and freeze point. Cloud point is the temperature when waxy material starts to form as the temperature of jet fuel is being decreased. Freeze point is a related property and is the temperature when the last wax molecule disappears as jet fuel is being warmed. These specifications exist so that jet fuel doesn't clog a filter when you are in a jet at high altitude, which would certainly not be a very good thing. Diesel fuel has a cetane specification, which is the diesel version of octane. It also has a flash point specification, similar to kerosene, potentially cloud point, and what is called a pour point specification. Pour point is the temperature when the material literally cannot be poured if you had it in a jar and tried to tilt it sideways.